Hello. Where do we come from? At least part of the answer is we come from the web of life. How does America think about the web of life? Luckily, that classic rock band told us exactly this in their 1971 platinum hit, A Horse with No Name. The lead singer tells us of his foray into the desert, how he rode into the desert with a horse with no name. He observes, the heat was hot, which is something we can all agree with, and we have experienced many times. He then gives an all-encompassing description of the web of life that surrounds him on this epic journey. There were plants and birds and rocks and things. You have to admit that pretty much does cover it. It might be a bit of a drawback that there are no specific names for all these plants and birds and rocks and things, and that, of course, his horse has no name either. But there's no doubt he appreciates the nature that surrounds him. This reminds me of a service that Katya and I gave some years back, in which we related how dill in our backyard garden was covered with caterpillars. To save the crop, we put the caterpillars in jars with the kinds of things they eat, namely plants and birds and rocks and things. Well, okay, mostly just leaves. That's what caterpillars eat, right? Well, no. Come to think of it, we probably gave them leaves of pecan, Siberian elm, Chinese pistache, mulberry, none of which they would eat. Our caterpillars languished, and we didn't want them to die, so we began to feed them dill. The pest upon our crop had now become a new crop we were raising, and the former crop was now its fodder. But at least we had learned one fact in the web of life, that Black American swallowtails are picky eaters. Now, the seventh principle tells us to respect the interdependent web of life of which we are a part. And as good UUs, Katya and I certainly tried to do that, but I'm afraid we've mostly failed so far. Just shoving some green leaves in the direction of some caterpillars is not how you respect the interdependent web of life. Really, you might need to get to know the species and their usual foods. I had thought that the worst of my ecological ignorance was past until recently when I read Douglas Tallamy's Nature's Best Hope. Then I was shocked to discover that our attempts to be green were just about as informed as our caterpillar feeding techniques, or about as informed as the guy on the horse. We were lacking basic information about how the web of life fits together. And because of that, we were creating ecological problems rather than fixing them. It was an aha moment. Katya and I originally had reservations about doing a service, but we both are teachers, and here was something we thought everybody needed to know, and that we wished we had known earlier. The big picture is this: all life is based on plants, which use sunlight to convert inorganic soil into living tissue. Plants, in turn, feed on animals, either directly or indirectly, in terms of birds eating insects, for instance. In fact, most of the energy transfer from plants to animals is done by insects. Now, insects don't eat just any plants. Over millions of years, plants and insects have co-evolved in what is sometimes described as an arms race. Plants have developed defenses against being eaten, and insects have learned how to get around them. The relationship between monarch butterflies and milkweed is a great example of this co-evolutionary arms race. Earlier, this was a very silly skit, and in order to avoid boredom, I've kept some of the anthropomorphization, giving intentions to caterpillars and plants alike. Here's the blow-by-blow. Over thousands and thousands of years, monarchs started eating milkweed, so milkweed evolved to be hairy and thus harder to eat. In response, monarch caterpillars evolved a behavior of mowing down the hairs on the leaves so that they would be easier to eat. The milkweed responded with a terrible blow, deploying a sticky, milky, poisonous goo that smothers caterpillars. Caterpillars shouted and made disrespectful gestures, and then developed techniques of building protective moats around themselves so that when the goo flowed, they would be safe. The milkweed riposted with even more awful goo. Monarchs swung into action with a new and awesome technique, biting the stem of the leaf so that it fell and no awful goo could flow. Not to be outfoxed, the milkweed countered by putting toxins into its leaves, making them poisonous to eat. After some terrible choking and spitting, the monarch struck back with a flurry of special adaptations, allowing them not only to eat poison, but also to store the poisons in their body, giving them a defense against predatory birds. The milkweed cursed the monarch and developed a secret whistle to call in parasitic wasps that would attack the monarch. Now, many scientists who study monarchs and milkweed are probably unaware of some of these details that I have revealed here. Even so, they will probably agree with the bigger picture. The list of evolutionary developments is pretty accurate, and it gives us a rough idea of what coevolution is and how it creates a very specialized bug. Specialization is not true just of monarchs. Different plants have different defenses. Insects and other herbivores cannot eat just anything. As a result, it turns out that 90% of insects are specialists. Each one of these specialized relations is a very specific connection in the web of life. Where do we come from? Mystery. One reason the web of life is mysterious is that it stretches farther than we usually imagine. Consider the caterpillars Katya and I had placed in jars so they wouldn't be eating our garden dill. Even though we gave them plants and birds and rocks and things, they refused our offerings. We didn't want them to die, so we began picking dill from our garden, bringing it into the house and feeding the caterpillars in jars. After a while, that seemed pretty dumb. Why so much human labor? So we put the caterpillars back outside on the dill plants, and they were very happy munching away there, at least for a while. But one morning we went out, there were no caterpillars left, or actually only one. There was a very fat bird sitting on a branch nearby, looking around, whistling like nothing had happened. Where were the caterpillars? Well, as I already mentioned, monarch caterpillars have learned to sequester poison in their bodies. In turn, birds have learned that nasty tasting caterpillars have these bright colors that mean don't eat. American black swallowtails saw how well this worked for the monarch caterpillars and decided they would evolve to mimic the monarch caterpillar. They didn't really decide, of course. So long as there are real monarch caterpillars around, the birds continue to learn this nasty lesson. And then the American swallowtail butterflies will be perfectly safe. That's a good plan as long as there are lots of monarch caterpillars. But now that monarch numbers are so terribly low, birds aren't learning that lesson anymore, and the mimicry no longer saves the black swallowtail butterfly caterpillars. Now, that kind of connection is not very easy to see. How can it be that cutting down a field of milkweed in Iowa to put up a subdivision can affect the caterpillars that are in our own backyard? But it does happen that way because of the connection through the monarchs. Coevolution sometimes produces cooperative relationships as well as competitive ones. I hope you saw it last Sunday in the Las Cruces Sun News. Marcy Scott posted a column about how coevolution creates the web of life. One example she gave is hummingbirds that specialize in certain flowers as they migrate. To quote her, "In our corner of the world, our beloved and familiar hummingbirds are specialists during the months they are migrating. for they need the high sucrose nectar provided by wildflowers to fuel their long journeys. Fortunately, the coevolution of their migratory paths and many flower species that especially cater to birds has, over hundreds of thousands of years, resulted in a very effective distribution of critical nectar resources. As with milkweed and monarch migration, if those flowers are removed, that's the end of her quote. As with milkweed and monarch migration, if those flowers are removed from one stage of the hummingbird journey, that's not just a problem for the flowers, but the hummingbirds and all the flowers the hummingbirds pollinate. Peter Wohlleben, in his book, The Secret Wisdom of Nature, cites a famous case of the web of life having connections that we don't expect it to have. Wolves were eliminated from Yellowstone Park in about 1930. Soon, the elk population multiplied. It stripped large areas, particularly the saplings that grew by the river's edges. That's bad news for the beavers, which soon disappeared. And without vegetation to hold the soil, the riverbanks eroded and the rivers began to meander more and more. The bottom line, no wolves meant a lot of elk, and a lot of elk meant a lot of problems. Wolves were reintroduced in 1995, and they soon reduced the elk population. Moreover, the presence of wolves changed elk behavior, so they no longer lingered on the sides of the rivers, but instead sought safer cover. With less browsing, the trees grew back on the riversides, and that stabilized the soil. The beavers returned and built dams again, and that created more room for amphibians and birds. Fewer elk meant also more food for the grizzlies and the bison, and their numbers went up. Excuse me. So it was that taking wolves out of the system put it out of balance, and putting them back in restored it. Sometimes it can be very hard to see these connections. The emerald ash borer is a non-native invasive species, small green bug that burrows into the ash tree. Native plants have no shared evolutionary history with it, so they have not evolved adequate defenses. Emerald ash borers therefore kill an awful lot of trees. But how many humans have the borers killed? That seems like a very strange question. But we do know there's correlation between exposure to nature and improved health outcomes, so it seemed logical to ask, would the loss of 100 million ash trees to the emerald ash borer correlate to higher human mortality? Researchers studied the data from 15 states from 1990 to 2007. They found the infestations were associated with 6,113 additional respiratory deaths and 15,080 additional cardiac deaths. So that's over 20,000 more deaths associated with the tree deforestation. This is not the kind of association a person expects to find between bugs and excess human deaths, and surely it would be hard to predict. This is one of those things that Wohlleben is talking about when he's speaking of the secret wisdom of nature. He's referring to the self-regulating web of life. Wolves limit elk, sure, but there are many more examples and we won't be able to know them all. We do come from the web of life, but many of its connections remain a mystery. Non-native plants are parts that come from a different web, like pieces from a different engine, and they won't fit into the engine we use. They mostly won't have connections to or participate in the local web of life. Yes, they would eventually evolve to fit in there, but that will take eons. And in that time, the currently existing system ecosystem will be destroyed. Talami asks us to consider Portland a very green city, but one where more than 90% of the trees are not native to the region. That means nearly all of Portland's trees lack the evolutionary history with the local wildlife that is required to contribute meaningfully to the food webs that support them. Portlanders' choice of non-native landscape plants has lowered the carrying capacity of the city to the point that during the bird breeding season, it is a silent city. The birds do not live in Portland. This kind of thing has happened across the globe as humans have developed more and more land, replacing more and more native habitat with non-natives. Talami cites the biologist E.O. Wilson, who argues that we need to set aside 1/2 of the Earth if we are to prevent the 6th great extinction. That is what we need to do to save the Earth's biodiversity. UN reports agree, but how can we do that with 8 billion people on the planet? Talami's answer is, at least partly, that we should convert our yards into a homegrown national park. There are about 40 million acres of lawn in the United States. This feeds almost nothing, yet it uses huge amounts of water, fertilizer, and pesticides. I believe the water use rivals our use for agriculture, for everything we grow for food. Likewise, Americans typically plant Asian or Mediterranean shrubs that contribute little or nothing to our local web of life. You may remember the great die-off of migratory birds this past fall. Martha Desmond, an avian ecologist at NMSU, called it unprecedented. She estimates that hundreds of thousands, possibly even up to 1 million birds died. It's enormous, the extent of this, she said. Researchers found that nearly all the birds were severely emaciated, already starving when they moved into New Mexico. This, of course, raises the question, why were they starving? Did they lose food sources because of development or farming? At around that time, some migrant birds were in our backyard eating bugs off of native trees that happened to be there. Talami recommends planting more resources for migrant birds, and so I wonder, if we created more resources in our backyard, would that help? I suspect here is something that humans have broken, something that Katya and I might be able to help fix. While I'm not sure about the specific case of the migratory birds, the overall conclusion seems sound. It's not enough that we stop destroying our natural habitats. We must actively work to reassemble them. As Talami puts it, wherever and whenever we can, we must reassemble the co-evolved relationships between plants and animals and among the animals themselves that enable ecosystems to produce the life support systems we all need. Introduced plants only hinder our efforts to do so. Now, of course, I'm no expert on this subject. I think a high schooler could write just as well as I. Those who are better informed are no doubt snickering right now at how small my knowledge is, and I don't disagree. I hope to listen to Marcy Scott and others, local people who know what the local plants are. For instance, her advice is that commercially available milkweed, what you can buy around here, usually doesn't survive. So, and I say, okay, Engelmann's milkweed, yep, right. I shudder to think that we were preparing to fill our backyard, which is currently pretty barren, with plants that we simply thought were pretty or were nice and hardy, without any consideration of how they would fit into the web of life. I'm glad I read Ptolemy at first, before we did that, and I'm glad I can share what little I have learned. I'm hoping to learn a lot more. By the way, a story is told about a river that flowed. It made me sad to think it was dead. If anybody knows the real chords to A Horse with No Name, I sure could use some help with those.